now. Okay, so we're recording, which means this may destroy my next class, and I will try to post this up here for you guys to see as well. So this is where we're going to be at. Now, we're talking about functions, and what I wanted to do really quickly is to start our notes today on the top of this page with a reminder from yesterday. Do you guys remember what was our definition of a function? Because this is something that like I would love to be able to have you guys look at it and go, oh, definition is this, and you just go through it. But I would also be happy to tell you again. But it's important to kind of review this a little bit, because since we're about to test whether something is or is not a function, it's going to be helpful for us to kind of look at this. And Greg did a really good job. For every input, there is an output. And I want to even add to that, not just an output, but exactly one output. Because the one thing that we're going to start thinking about is there are some situations where an input value might give us more than one. And if that's the case, then it can be a relationship. It just can't be a function. So when we're talking about a function, we're doing this where every input, I'm going to try to write it neatly enough that you guys can see it, has exactly one output. And when I'm thinking about that part as well, yeah, that wasn't super neat, but I guess that's okay. Our input values are our X values. Our output values are our Y values. So every X value gives me exactly one Y value, and we're going to be doing something as a function. And now, here's the thing. Sometimes seeing this is really easy to do if you're looking at a table. You can see that every X value has exactly one Y value. And so what I'd like to do for just a second, before we get into the notes of all of the stuff that we're going to be doing here, I'd really like to have us take a second. I'm going to flip to the back page, and I want to write a couple tables to sort of show you what it is that I'm talking about. Because there will be some times that you'll be given that representation of a function, and you're going to be asked, does this table represent a function? And I want to make sure that you don't get caught by surprise with something like that, because what tends to happen is they're pretty easy problems, but if we haven't put you in the situation, it becomes something where it gets confusing. So what I'm about to do, equally confusing, is I'm going to go on the back of this page to write a couple examples down. Okay, so I'm on 3 right now. We'll call this 3.5, and I'm just going to write a couple things down on here when we look at a table. And so here, I'll put this right there. And what we have to remember is that what we're looking for, every X value has exactly one Y value, okay? So I'm just going to give you an example to start with. There's an XY. And I'm going to start to write the values down. As soon as we get to something where you feel like it's not a function anymore, I want you to either unmute yourself and say stop, or to type in the chat, not a function, or stop, or something like that. And we'll kind of go from there. So I'm just going to start writing some points down. We'll have 2, 7. And then I'm going to go -3, 5. Okay. And then I'm going to go 6, 4. And then I'm going to go -8, 15. Are we a function so far? Is this okay? Is every X value have exactly one Y value? So you're going to type yes or no in the chat so I can kind of see that. Is this a function so far? Yeah, I would agree. Right now, every X value has exactly one Y. Okay, I'm going to do a couple more here. We're going to go 7, 21. And then I'm going to go 6, 8. And then I am going to go maybe to something else. I got a question. Is this 6, 8 keep this a function? Let's see, says no. And let's see, you're right. In the case of something like this, when we look at what happens, what we're looking for are input values, our X values. So up until here, every input had exactly one output. 2 went to 7, -3 went to 5, 6 went to 4, -8 went to 15. As soon as I get to a repeated X value, I have to think about that for a second. 6 has to go to 4. That's what we had up here. As soon as I get 6 also going to 8, that means that this input value 6 gives us more than one output value. So what I'm going to do here is say, so here, same input. And I'm going to put boxes around these, and I'm going to say different outputs. As soon as I get to something like that, not a function. Now, here is another thing that I want us to do for a minute. And this is a really good way of sort of writing this out as we figure this out, is sort of saying, what is it that I'm looking for? In this case, a repeated input. They gave me two different outputs, not a function. Now, I'm going to change the color so we can kind of look at it and you know that I'm dealing with a different example. So this is a completely different example that we're looking at over here on the right. And I'm going to give us another table. Trying to make sure everything fits okay. Sorry, it's hard when I go on the back of these pages. They're not designed to sort of be this way. But so if I do this one here, we'll have an X, we'll have a Y. Okay. Right now, I'm going to go 2, 7, 3, 7, 5, 7, 8, 7, and 9, 7. Is this a function? Type in what you think. Is this a function? Yes or no? We've got one yes. We've got one no. Let's think about it for a second. So I've got more than one no and one yes. I'm going to ask the question, does every input have exactly one output? I'm not asking about does every output match with exactly one input. I am saying, does every input value, every X, go with exactly one Y? Did 2 go with anything other than 7? Right now, I only have the 1, 2. 2 goes with 7. 3 only goes with 7. 5 only goes with 7. Now, the output is repeated, but it doesn't matter if the output is repeated as long as none of my inputs has more than one output. Each input is only paired with one thing. That's okay. I'm following my definition. This is a function because I have no repeated inputs. As long as my inputs don't repeat, I'm good. Now, if I have all of a sudden a 2, 8, done. It's not a function. The Y values can repeat. It's totally okay for the Y value to repeat. That's fine. The X values cannot. And so that's the thing that I want you guys to write down, is that the table test for functions what you're going to do is you're going to look for repeated X values. And the reason you're looking for repeated X values is because if an X value repeats, that means that you have an input that has more than one output. So it's not a function, like this 6, 4 and this 6, 8 that we had from before. In this case, since none of my X values repeat, each of them has the same output, but it doesn't matter because they each have one output. It's totally fine. And if you think about it, one of the things that we did in Algebra 1, we were talking about functionality. I think they used like a vending machine or something like that, where if you clicked a button, it would give you, like, you click a button and then it gives you a soda. Nope. Sorry, I forgot to turn those things off. It's Wednesday, but it's not exactly Wednesday. So sorry about that. So like what we would do is we'd say it's a function if you'd hit the button and the same thing comes out each time. Now that doesn't mean that there isn't more than one button that gives you a Diet Coke. You could have more than one button that gives you a Diet Coke. The machine still functions. It just means that you click that button, it always gives you the same thing. And it would really stink if you had a vending machine. What you really, really wanted was that candy bar right in the middle. And you hit a button and it gave you something else. And then you hit the button and it gave you that candy bar, and you hit the same button and it gave you a candy bar over here. Functions mean if I hit a button, it's going to always give me the same thing. Even if all of these things give me 7, it's still a function because 2 always gives me 7, 3 always gives me 7, 5 always gives me 7. If 5 gave me something else as well, then it's not a function, okay? Now, here's what I want to do. This is with the table. And again, we're just looking for repeated x values if it's a table test. What I want to do now is talk about how that works with a graph. So I'm going to go back to the page that we actually had stuff written down on. We're going to start working with this one for a minute, because we have two graphs over here. We've got an oval, which is called an ellipse. We've got a U, which is called a parabola. Two different types of mathematical graphs. Both of these come from equations, so I can represent them with equations. What we're going to try to do, check to see if these are functions or not. Now, I'm going to ask, without anybody giving anything away, does anybody remember what the test is for a graph to see if it's a function or not? If you remember it, type yes, I remember in the chat. And if you don't, it's okay. You can type a no as well. It's fine. I'm going to teach it to you regardless. Got some no's. When I say it, you're going to remember it because you definitely learned this in Algebra 1. So here's what we're going to do. What we're remembering is that every input, every x, has exactly one y. So no x values repeat. And so because of that, what they're telling you to do to start with this is they're giving you the x value we're going to test, okay? They're going to say, we're going to check for x equals 3. And graphically, if you can graph every place that x equals 3, what you're drawing is a vertical line. So I do want to make sure that you understand this. So it asks you to draw a vertical line. By the way, vertical is just up and down. So this is going to be like parallel with the y-axis, whose equation is x equals 3 on both graphs. So what they're going to ask us to do is they're giving us a test. This would be like if I looked at the table of values, I'm going to see, does that 3 repeat? Okay. And so what we're going to do is go to both graphs, and we're going to draw this vertical line. So I'm going to go here, x equals 3. I always go on the x-axis to start. So x equals 3 starts right here. And what we have to remember is that if the only thing that I'm worried about is the x, that means y can be anything. So I could have this one on here, or I could have 3, 1, or I could have 3, 2, or I could have 3, 3. All of these values on this vertical line tell us that x is equal to 3. So I'm just going to keep drawing them up and down. And right up on the top here, I'm going to write x equals 3. I'm going to do exactly the same thing down on the bottom here, because they're telling us with this vertical line, we're testing it to see, are there any values for x equals 3 in both different spaces, okay? Now, here's what you want to do, okay? So we've got these both drawn, one on the top one on the bottom one. And what we're going to do then is to see when x equals 3, what do we get on our graph? Now, the graph is just the representation of all our input and output pairs. So what I'm going to do is I'm going to kind of give us a cheat here for a second. We're going to make, for both of these relationships, a quick table of values. And what we're going to do, so we'll have an x and a y, we'll have an x and a y. And what I want to do is, I know that 3 is what the x is. I want to see, looking at the graph, what y value on that graph goes along with it. Now, this one down here in the bottom, it's easier to keep the table and the graph in the picture at the same time. I'm going to have to slide it up to get to the oval up there. So let's look at this one first. We look at this. We have our vertical line here at x equals 3. So that's all the points where x equals 3. This graph here, this parabola, is all of the points that are the pairs of things that are my function. So what I want to do is go and see, what do I get out at x equals 3 on this graph? I get this point right here is on the graph. So I'm going to draw a little arrow there. That's the place where x is equal to 3. Can somebody tell me, what does y equal at that place? Just at this point right here, what does y equal? You can type it in the chat, that'd be fine. If you're not sure where to look, just look over to the side and see where this goes across on the y-axis. What is the y value that goes along with the x at this point? 2 is close. We got to remember it's down here, so it's the -2 we're looking at. At this point, when x is equal to 3, y is equal to -2. So that would be my output value that goes with this input in relationship B. Now, what I do then is I look at this vertical line, because this is every place where we have the input value of x equals 3. And I'm going to look up here and see anywhere up here, does this cross the graph at all up here? And as I look, I don't see any part of the parabola up here. It crosses it right there. And if I keep going, there's no more part of the graph. So right now, there's only this one value that I get when I plug in an x equals 3. I'm going to get out a y equals -2. So right now, that's as far as I've got for that first one. Let me slide this up and see what we can find on the graph above that oval. So if I do this x equals 3, let's go up first. We go up here, there's nothing yet. Here's the first place that I see this intersecting. What is the y value right here? If I have that, crosses my graph there, what's the y value if I go across and look? Five is close. It's actually a little less than 5. In this case, it's actually 4 if we count how far that up is. 1, 2, 3, 4. So y equals 4. So I'm going to go back to my table over here. We have 3 and we have 4. Now, here's what you've got to do. We've got to check all of them. If I keep going this way, there is no more graph, so it doesn't cross anything that way. But if I go down, what you'll notice crosses that guy again right here. And this is at the place y is equal to 1, 2, 3, 4, -4. So that means that as I look at this, 3 also gives me -4 in this case. So when we think back to what we just talked about with our tables, in this case, my input of 3 only gives me -2. Each input gives exactly one output. This relationship B, that's a function because each input gives exactly one output. If I look at this one, 3 gives me 4, but 3 also gives me -4. So in this case, this one here is not a function. And this one right here is a function. Now, what I really like about the way that this book is asking us to describe this is it says here, explain which is a function and why. Now, here's what I want to do for just a second, okay? We know that this is not a function, and this gives me a chance to talk for just a second about how you get to the explanation of why when you're doing some of these things on tests. So for example, when we have a constructing argument and ask you to explain why something is the way that it is, I want to tell you something that I need you to start to think about, okay? Some of you guys have done a really, really good job of like putting lots of words on the page and explaining to me why something is. But the problem that I'm starting to get is I'm starting to get people saying things on their tests that are like, I don't know, or I don't remember, or I'm not good at math. Those are words, but I can't give you any points for those words. So I want to give you something that you can do. If you don't know how to do this, I want to tell you what you can do to start to come up with some things, even if you don't know the full answer. And here's what you can do. When I'm looking for why, I need to look and see what it is they're asking about. They're asking about which one is a function. Okay, so in my head, I think it's a function. I remember there was a definition of a function, okay? So when I write my explanation, I want to find the definition. We wrote it here. Every input has one output, exactly one output. If I don't know enough about this, I need to use these words somewhere in my definition, somewhere in my explanation. Because if I use that, I know that this is the thing that relates to this idea. And so that gives me words that at least tells the math teacher, I understand what I'm supposed to be talking about, but maybe I don't understand all the details there. And that's a really easy way to start these. Find the definition. Find the thing in the notes that explains what it is we're talking about. Because even if you haven't written this stuff down, on Google Classroom, you have a copy of these notes that are the printed version of all of this. Go to that. Look and see what it says and say, okay, I'm looking at that there. There's a function. Each input has exactly one output. I'm using those words to start. Even if you just type, each input has one output, period. Then whatever you add afterwards is going to be stuff that adds your knowledge to that. But it gives me something to start with. When you write, I don't know, that's the point value I have to give you. I got to give you a 0, and I don't want to do that. Each input has exactly one output, and then try to relate it to what you're looking at here. So let's look for a second. This one is not a function. We've said that below here. So I'm going to show you an example of how we would write that for explaining why this one isn't a function. And I'll do a little arrow down here, and I'll do here. I'm going to do this in this color. So I'll write this definition below here. I'm going to say Relationship, I'll do REL, A, is not a function because now, as soon as I've started this, now I'm going to use something with the definition, with the inputs and the outputs, because the input 3 has 2 outputs. And I'm going to put in parentheses here 4 and -4, period. Right now, I used the definition. I showed that this doesn't follow the definition, and I explained that it was not a function. This is a 5 out of 5. It explains exactly why and uses the definition. Now, let's say instead, I want to do this thing with relationship B and explain this. We said that this is a function. If I'm saying that something is something, all I have to do is use the definition. Relationship B is a function because. Now, all I'm going to do now is use my definition. Each input has exactly one output. And at this point, I'm done. Those are two perfectly worded constructing arguments that use the definition, and we go through this. Now, let's say you had no idea what the answer of this. If you write something like that, even if you're completely wrong, you know what? I know you know what you're looking at for a function. I would probably give you at least a C on this problem just based upon the fact that you used the words of the definition and you wrote it in a sentence. Done. Now, if it asks you if this is a function and you said yes because each input has exactly one output, you'd be wrong, but you used the right definition, so you're getting points. And that's what I want, okay? Here's the other thing that I want to tell you about before we even get to this vertical line test thing on the bottom, and I'll get to that in a second. Guys, I've graded a bunch of critiquing problems, okay? One of the parts of a critiquing the reasoning problems is identify the mistake. Most of you guys do a pretty good job of saying that's wrong. You could see it, you explain what's wrong. Then it says, why is it a mistake? I am not asking what would happen if they do this. I'm asking why is that thing wrong? It's wrong because when you multiply a negative times a negative, it should be a positive. It's wrong because they distributed the number the wrong way. They should have done this. It's wrong because they were supposed to add the exponents instead of multiplying them. Anything like that is explaining what they should have done. I am not looking for you to say, if they do this, they will get the wrong answer. Of course they will get the wrong answer. That's why we made the mistake. If there's a mistake, they will get the wrong answer. You don't have to tell me that. I want you to tell me why is that thing that they did not correct. That's what I'm looking for. So when you write it, they did this thing that you said. Then just say why that shouldn't have been. Not because the answer is going to be wrong, but because when you do this math rule, this is what should happen, okay? Because probably 50% of you, when you have written critiquing problems, your reason is because you would get the wrong answer. It's not what I'm looking for, okay? Tell me why the math is wrong. Man, I'm glad I got that out. I feel much better. Woo! That's awesome. I've been holding that in since yesterday. I graded all the stuff that you guys had for the test. And I looked at it, I'm like, if I see this one more time, I'm going to set fire to the computer, and that's not what we need. Then I won't be able to have a Zoom. Okay. Last part. This is the test for graphs. And this whole rule that we have here kind of helps us to sort of go through this. It was called the vertical line test. Now, how many of you guys remember from back in Algebra 1, the vertical line test? If you remember that, type yes. If you don't, you can type no. It's totally fine. I know it was taught to you. Vertical line test. If you remember it, write yes. If you don't, write no. Some no's. Max, I taught that to you directly, so I don't even want to hear that business. You too, Aaron. Both of you guys. I taught you both. This is, by the way, recorded, so when it comes back, you're going to get yelled at on a recording and other people will watch. That'll be great. I didn't say your last names, though, so. All right, guys, here's the deal. This is, and we could do a constructing arguments, but we kind of already talked about it. So let's just talk about the vertical line test. So I'm going to write this down. It would be a good idea for you to write it as well. Vertical line test for function graphs. And it goes like this. If a vertical line crosses a graph more than once, that graph is not a function. Now, here's the thing. Normally, that is where we stop. You just draw a vertical line, you see, does it cross more than once? If it doesn't, it's a function. If it does, it's not a function. I want to explain why, though, so that if you have to use this later, you can use this part in your constructing arguments. I'm even going to change colors. Not a function, because that input x equals number, because every vertical line follows this idea. It's x equals some number, whatever it's going to be, has more than one output on the graph. That is the reason why the vertical line test works. Now, what I'm going to do below here is just give you a couple examples, and we're going to do functions and not functions. And I think some of you, this might be something that you'll go, oh, I kind of remember this now. And if you don't, that's okay. What I'm going to do, let me slide this up a little bit, and I'm going to just do a couple basic sketches of graphs. So let's go. Here's some examples. These will be x, y coordinates, and we're just going to write function or not function underneath here. And actually, I did something in the last class that worked out really well. I took out a piece of lead to use as a vertical line. So we'll use that here too. And I'm just going to do a really quick graph. So right now, what I'm going to do is I'm going to do a graph just like this. Okay. And if I look at that, we're going to go and we're going to take a vertical line and I'm just going to slide it across here. If it doesn't cross more than once at any point in time on that red graph, then this has to be a function. Is there any point in time as I did this that this crossed the graph more than once? Anybody see it crossing more than once? Nobody's typing anything. So I'm going to tell you, no, it didn't. And one of the things you can do, you can actually just kind of quickly sketch them as you go and say, well, no, right now, each of these only crosses once. So this is a function. But what if I've got one that looks like this? If I do that, can you guys see that the vertical line will cross this more than one time? If I look right there, I could draw a vertical line right along this. It would cross here and it would cross here, which means this x value here has a y value up and a y value down. This input has more than one output. So this will not be a function. Now, how many of you guys remember what I just did there? Does that make sense with what I just did? How many of you guys remember this? If you say, I do, that will help me. If you say, I don't, that's okay too. I just want to see where people are at. So we're kind of running out of time and I want to make sure I have enough. Somebody's got to give me something here. Anybody remember? Y'all, your silence is deafening. So here's what we're going to do. I have in your homework assignment the following thing, and I'm about to change my share for just a second so you can see this, okay? We're almost done with class, so if I can do this, I think it will be helpful. When you look at your classroom assignment, one of the things you're going to have is the 2.1 homework is right here. And when you look at it, thank you, and I appreciate that. It means a lot. One of the things you're going to have for these slides is a really cool thing, which is asking you to check with a vertical line to see if it's a function or if it's not. And as we're looking at this, we've got some graphs and they give you a vertical line right here. As soon as you highlight it, you can use your arrows to move it around. So like if I look at this and I bring it down here, I'm just going to start moving it this way. So right now, I look, Does this ever cross the graph more than once? No, it doesn't look like it's crossing that graph more than once. So this would have to be a function because every input has exactly one output. But if I go over here for problem A, if I look right there, if you notice, I've got a point right there, and I've got a point right here when I have the vertical line. If it crosses it more than once, this is not a function, and you'll type that in the bottom. And that's what it is that we're going to be looking for you guys to do for the homework assignment, which is up here. And most of it's just check with this and then type in the bottom function or not a function. So I'm going to stop sharing and say to you guys, I think that's enough for what we're going to be doing today. I'm going to stop.